Hey guys, so this is going to be a video where we're going to briefly go over how to successfully neutralize a single vision lens with vertical prism. So right here I have just one of the glasses we've used in the lab many times, and over here on this side I have the prescription as I've read it off of these glasses with the OD and OS. In case you can't read my handwriting, the OD is minus 337, minus 187 at 173. The left eye is minus 475, minus 75 at 27. So the idea with successfully neutralizing a single vision lens with vertical prism is first, of course, to just neutralize the glasses, which I've already done. Now, I've taken the two prescriptions, first the right eye, the OD, and put it into an optical cross, which you're all familiar with, and the left eye into also an optical cross under the OS, and set them up with little question marks in the 90th meridian. So the question really becomes is once we set this up is which lens has the stronger power, or in essence the larger number at 90 degrees. So in this case both the lenses are minus power, but it wouldn't matter if one was minus and one was plus. Whichever one has the larger number is the one we're going to be looking for. So again, I've got the two prescriptions, I've got the two optical crosses, and now the question just becomes which lens has the stronger power. So if I look at the optical cross, which I have done here and here, you can kind of look at it, and these two I picked on purpose because the power at 90 are very close, and it's going to force us to go to the most important next step, which is doing the power in the oblique meridian formula. But if you happen to have a situation in which the lenses are obviously stronger or weaker, and you set it up in an optical cross format, you're going to be able to easily see which lens has the stronger power at 90. In this case, we've got the right lens, which 525 to 3.375 is kind of in and around 90, and then 525 down to 475 is also in and around 90. So again, in this case, we're not going to be 100% sure. So I'm going to flip here to a second page, which I have now laid out the power and oblique meridian formulas. So first I took the right eye, and I've got the prescription as written, minus 337, minus 187 at 173. And then I set up the power and the oblique meridian formula, which I have the 337 minus 187. And now I need to take the sine of 83 squared, because we have to get to 90 degrees. So essentially I'm taking 173, subtracting 90, and that's where I'm getting it 83 degrees away. So I go ahead and complete the formula. Sine of 83 squared is going to be 0.985. If you round it, you're going to get a pretty similar answer. Bring it all the way down to where I'm multiplying these two together, and I'm getting 185, 337, 3.375 minus 1.85, it's going to give me minus 5.225 at 90 degrees. So in the right eye, the power at 90 is minus 5.225. In the left eye, when I do the exact same thing, this time it's using the left eye prescription of minus 4.75 minus 0.75 at 27. Now I'm going to use the sine of 63, because the original prescription, if you remember, we'll flip back to the previous page so you can see it, was at 27. To get from 27 to 90, we are going to go 63 degrees, or 90 minus 27 is 63. So when I take the sine of 63 squared and gives me 0.79, I multiply that by 0.75, it's going to give me 475 minus 0.59. That's going to give me a power of minus 5.34 at 90 degrees. So when I do the two oblique formulas and end up with 5.225 at 90 in the right eye, 5.34 at 90 in the left eye has the stronger prescription at 90 degrees. Therefore, that's what we needed to find out. Once we've done that, I've got some notes here. Once we've done that and we've decided that the left lens has the stronger power at 90 degrees, we therefore then need to center the left lens, the OS, in the center of the targeted lensometer grid, and then dot that lens. And there's going to be an accompanied video I'm going to show you inside the lensometer that's going to go with all of this information. So once I then center the left lens right in the middle of the target, just like if the lens had no prism and we dot it, we're then going to slide the glasses over to the right. Once the right gets centered along the 90-degree axis or the 90th meridian, which I'll show you in that other video, you're going to then dot that lens. So in essence, you're going to end up with all the dots going straight across in the same plane. Once you've done that, you're going to be able to see how much vertical prism exists between both lenses. In essence, if I dot the center lens, the left lens right in the center, and then slide it over to the right, it's not going to be in the center. It's going to be either above or it's going to be below. Once I determine whether it's above or below, I'll be able to determine exactly how much using the lensometer grids that you guys have become all too familiar with. So we go to the last page here. Once we've seen how much vertical prism exists, whether it's 1 up, 2 up, 3 down, a half down, it doesn't matter. We're going to write out that existing prism in the weaker lens. And again, I'll show you in the second video. I do want you to know that to successfully neutralize a pair of glasses with vertical prism, if you were in a retail environment, you must know what the original OC height was for that patient's glasses. If you don't know that, you don't know how they were originally ordered, you really have no idea how much vertical prism truly exists in those glasses. So just for your own retail experience, if you do not know what the vertical positioning or the OC height was for the original glasses, then you cannot accurately neutralize a pair of glasses with vertical prism. Otherwise, you're only guessing what it could have been. So if the glasses were made in your store, it's easy. You can look up what the original OC height was, and then you can dot that mark and be able to determine exactly how much vertical prism. If you're just guessing, you are just guessing. This is really the only effective tool we have to try to successfully neutralize a pair of glasses with vertical prism. But I'll get into more on that with the second video. Thanks.